This is an overview of Newton's laws. There are three Newtonian laws, and we'll be studying those in this chapter and the next chapter. The first law is the law of inertia, which says that objects move with uniform velocity unless acted on by a non-zero net force. So this word net just means the sum of all the forces, and a force intuitively is a push or a pull. An example of this law of inertia is the fact that if you take a large mass and you go to a place where there is no gravity, let us say outer space, it's still difficult to shake this large mass back and forth because it has inertia. It resists your effort to shake it back and forth. And so that word I use, mass, introduces another quantity here that we'll be talking about in relationship to Newton's laws, and that is mass, which quantifies inertia and also the quantity of matter. Newton's second law relates the net force and the acceleration that a body experiences. So what this says is that if a body with mass m has a net force acting upon it, it will accelerate according to this equation. So among other things, it means the acceleration will be in the direction of the net force, and acceleration is a vector, and so is force. So an example of this is free fall, where you have an object that is falling with no air resistance, either because it's in a vacuum or because we're ignoring air resistance. And so the force acting on it, the single force acting on such a body, would be its weight, which is its mass times the local gravitation, mg, down. And so from Newton number 2, that means that the acceleration is equal to the net force, which in this case is mg, divided by m, which is g. So this is something we've been assuming the last couple of chapters. And so this is the context for it, that a force is acting of magnitude mg is acting. Finally, there's the third law, which is the law of action and reaction, and the content of that law is that forces always come in pairs. There's always an object and an agent. It depends upon your context. So, for example, if you have two bodies, A and B, that are interacting with each other, let's say they're attracting each other, that's what this picture is showing, then if there is a force that B exerts on A, which I have drawn as this to the right force, F of B on A, then there must also exist a force of A on B, which is the same magnitude but oppositely directed. So we'll see many examples of all of these. An example of the Newton number 3 is a situation where if you take two spring scales and you hook them together and you pull on one to the left and I pull on the other one to the right, that both of these scales will read the same amount of force in newtons.